Welcome back to calculus. Let's do some examples. As we do these examples, I have the formula there for you, and you see they're really not that bad to set up. We don't even really need to sketch on these. The main thing you need is the derivative of f. So let's start with that. F prime at x is 2 times 3/2 x to the 1/2, and we could simplify that a bit, just calling it 3x to the 1/2. So ready to start a derivative now, or integral now, for arc length. Integral is going to go from 0 to 9. So the reason you don't really need a sketch is because the bounds are usually given like they are here. There's no inner, outer radius, p, h, any of that stuff. Then square root 1 plus this f prime squared. Don't forget your dx. So we'll simplify this a little bit. Notice the 1/2 is only on the x, not on the 3. So 3 is fully squared to be 9. X to the 1/2 is squared becomes x. This can be integrated like this. I'm going to do it the long way. Just those of you that are watching, you might want to be unsure. So substitutions, when in doubt, is a good idea when you're kind of unsure how chain rule is going to affect things. So we get here, and so 1/9 of du is dx. Okay. So this now is the square root of u, times 1/9 du. Now I left my bounds empty, and I gave a little extra space because we needed to change our bounds. Like that. And like that. Before we integrate, let's just do a little tidying up. We can bring the 1/9 out front. We can simplify our bounds. 1 to 82. We can write this as u the 1/2. That looks a little nicer. So this u becomes 3/2 now, and so we better put a 2/3 out front. The bounds are on that. So we end up with 2 over 27 times 82 to the 3/2 minus 1 to the 3/2. That's weird. But we can simplify that to be 2 over 27. We can't simplify this, but we can write that just as 1 on the end. And that's our arc length. Hopefully that makes sense. That's a pretty basic one. The next one is going to kind of show the hardest integration technique. And so let's jump into that one right away. This example is an unusual one. You're finding the arc length of this function here. 1/8 x to the 4th plus 1 over 4 x squared. And we're going to look at that from 1 to 2. Well, taking this derivative, this right here is 1/4 x to the -2, right? That might be easier to think of it. So the derivative will be 1/8 times 4x cubed plus 1/4 times -2 x to the -3. So we're left with 1/2 x cubed minus 1/2 x to the -3. That is a bit weird, isn't it? Okay, well, let's just plug in the formula and see what happens. So our formula for arc length, let's change colors, says L equals integral from 1 to 2. And I've kind of gone back and forth. What is the best way to show this? I'm going to do this. So I'm going to factor that 1/2 out. That just seems like it'd make life a lot easier, doesn't it? But all of that is squared. Just factor that out, right? Get the 1/2 out of there, get that out of there. It's just going to be easier to square. When you square it, this is 1. This becomes 1/4, and then you have to square this. I'm going to kind of show it in 2 steps. I'm going to do this squaring right here, up here. So it is x cubed minus x to the negative 3 times x cubed minus x to the negative 3. These are not conjugates. First is 6th. Outside is minus x to the 0, right? Inside minus x to the 0 last, plus x to the negative 6. Well, these become 1, 1. So we end up with this bizarre answer. So we have bounds 1 to 2. This is now 1 plus 1/4 times x to the 6th minus 2 plus x to the negative 6. Okay, again, I was thinking through the best way to do this. I'm going to distribute this. There are other ways. So this will become 1/4 x to the 6th minus 1/2 plus x, plus 1/4 x to the negative 6th. Okay, the reason I did that, why did I multiply it through all that? Because I want to get this 1 in the game, right? The 1 is just kind of waiting. Finally, 1 has a like term. So this becomes 1/4 x to the 6th plus 1/2. That's just strange, isn't it? It's exactly the same as we saw up here. That is the same as this, except for a sign. Only that sign right there distinguishes them. But what I want to get at is, well, let's get back to this. Let's factor the 1/4 out again. And this will become plus 2 plus 1, plus x to the negative 6th. Now, does that look familiar? Let's take a look at this. How do you get in here? This and this. Same except for that sign. Here it's a plus, here it's a minus. But look where this came from. It came from that. Could this bottom part look something like this top one? And therefore be something like that? Yeah. First of all, I can take that 1/4 out of the square root. We know the square root of 1/4. It's 1/2. And then this thing under here factors to x cubed plus x to the negative 3. Crazy. Oops, squared. Try it. If you FOIL that, you get this thing. It's the same as this up here. Oops, where'd it go? It's the same as this, except it's got a minus. This one has a minus, this one has a plus. Okay. So this 1/2 can pass all the way to the front. And then guess what? I'm squaring a square root, so this just becomes x cubed plus x to the negative 3 without the squared or anything. Take a deep breath. You've done the hard part. Now we have 1/2. We integrate this as 1/4 x to the 4th plus negative 1/2, right? And the bounds are 1 to 2. Now when you plug in, 1/4 times 2 to the 4th plus negative 1/2. This would be 1/2 squared. I'm writing it instead of the negative exponent. I'm just putting it in the denominator. Minus 1/4, 1 to the 4th, plus a negative 1/2. Put that all in bracket there. 1 over 1 squared. Lots of brackets here. This becomes 16, 4. Next one becomes 1/8. This becomes 1/4. And this is minus 1/2. You're getting somewhere. Okay, you might just want to fast forward me doing this tedious math here. This is what, 31 over 8. This is negative 1/4. And that becomes 1/2. That's a plus. So if you add those together, you get 33/8. And that becomes 33 over 16. And yes, that is our answer. Just over 2. Very tedious. That one not fun to do by hand. Very tedious. I think we're going to stop there. I got 2 more ones I want to do later. Hopefully that made sense. Looks like the answer